We're ready. All right, so if we take a look, this is unit 15. This is the last unit we're doing. Those of you going into AP, there may be a unit over the summer. I'm sorry, it's an oxidation reduction unit. It won't be that hard. I'll probably give a review of this class, and then a small, like, it'll take you like a half hour or something like that. Anyway, let's take a look. Here are the state standards. You can see not very many of them. Here are the standards-based objectives. They should, right? And we are going a little bit further. We're going to go into what's called the 5% rule. Hopefully, if we get to it, we will see. We losing Monday of every week has definitely caused us issues. So let's take a look here. Water. Water does something called self-ionization. So if you have H2O plus H2O, we know that the water molecule is polar. And sometimes these electrons on this oxygen right here can grab a hydrogen off of, what you do is you show a little arrow here going this way, showing the bond going back to this oxygen. It can grab that hydrogen off of there, and that makes this hydroxide have a -1 charge because it has an extra electron. And this hydrogen right here, this becomes what we call H3O plus, because it has this extra proton or hydrogen ion. So this is called self-ionization. This is known as the hydronium ion. If something is an acid, it makes more hydronium ion. This is known as the hydroxide ion. If something is a base, it increases the amount of hydroxide ions in the solution. Water is basically at equilibrium because for every one of these made, there is one of these made. And if these are in equal concentrations, then the substance is considered neutral. That would give water at, I believe, between 4 and 25. I think it might be 4 degrees Celsius. I don't know. I'll have to look that up, or you can look it up, but it's not that big a deal. It's not going to go much different than that. But the pH of that water, pure water, at that temperature is 7. 7 is right in the middle of what we call the pH scale. The pH scale goes from 0 to 14. So if you are less than 7, what are you? You guys have that from like 5th grade, right? Acid. And if you are greater than 7, you are a base. So the pH means parts hydrogen, or hydrogen ion. And basically that is the log, the negative log of the hydrogen ion concentration gives you the pH. The negative log of the hydrogen ion concentration equals the pH. So you guys know log, for example, right? So the log of this would be -7, right? Because this is base 10, right? So what is -7? 7. So the negative log of this, if this were the hydrogen ion concentration, it would be 7. Acids increase, I said that. Bases increase, I said that. Cool. I got all that covered with this formula up here, and that's good. And this is covered too. So identifying acids and bases. What if I put HCl plus water? Oops, I'm thinking into the future. What's it gonna form?
Cl minus and H2O plus.
H3O plus Cl minus. Again, we have that hydronium ion. So that increases the hydronium ion concentration. Hydronium ion, in my mind, is the same as the hydrogen ion because if it's in an aqueous solution, water will grab onto that, right? So HCl increases the hydronium ion. That is an acid. More hydronium. Also, if you look, what does it start with? Nope, if there's more hydronium, then it's an acid. What's that? The number what? Are you guys on like some chat channel or something? Is Gavin? Is it Gavin? It looks like it's Gavin. Is he being bad?
Yeah.
How about this? Calcium hydroxide. If we put calcium hydroxide in water, nope, not necessarily. Remember on the last unit, we had the solubility equilibrium. So what's going to happen to this if we put it in the water, if this is solid?
Ca 2 plus and 2 OH minus.
You get Ca 2 plus 2 OH minus. So what did we just increase? The amount hydroxide. That's that solubility thing from the last unit. When we take the cation and anion and separate them.
Yeah, I'm okay. I understand that, but I don't.
If it increases OH concentration, then it's a base. If it increases H plus concentration, then it's an acid.
In this, that's all.
I'm sorry.
That's all. That's all.
Yep, no weird exception.
Okay, so more hydrogen, less hydrogen.
Well, it's the hydrogen ion.
Right.
So H2SO4, what's that going to do? They're going to increase H plus or OH minus. H plus, so it's an acid. HF, what's that going to do?
Acid.
Acid. So what you're going to see is acids start with what element?
Hey,
H. How about NaOH?
base.
It's a base.
I know how to do it.
Lithium hydroxide?
Base.
Base.
Oh, I get tired.
It's completing the OH negative, right? If it ends in OH negative, it's a base. Or if it's a hydroxide, it's a base.
So it's, so acids only start with
So these two are
acid.
acids.
Ignore the math, like, start with that, then explain the math.
You started from like the hardest part.
What are you talking about?
That's so easy.
What are you
to
talking
power
about?
it. So easy.
Yeah, but this is the actual chemistry behind it. You know, here is the interesting thing. Certain acids are strong acids. And a strong acid does not tell you anything about its pH. The strength of an acid tells you how much it ionizes. So if we take a look, we know that if we were to find the equilibrium constant of this, now acids and bases have interesting equilibrium constants. Instead of this K, we call it Ka. Who goes on top? Products. So I'm just gonna abbreviate H3O plus as H plus because it's the same thing, and Cl minus. On bottom, we have the concentration of HCl. We're taking the H2O out. I took the H2O out here and I took the H2O out here. We're not worried about that. The Ka for HCl is incredibly large. It's incredibly large. So that's why it's a strong acid, because if this is large, what does that mean? What's favored, products or reactants? Products. It's almost 100% ionization. So for every 1 mole of HCl, it separates into 1 mole of hydrogen ions. Right? HF. We know HCl, can HCl do hydrogen bonding? No, remember the 3 elements that can? What are the 3 elements that can do hydrogen bonding?
NOF.
NOF, NOF, right? NOF. So HCl cannot do hydrogen bonding, right? So you're not going to have that intermolecular force holding that H onto the Cl. So it completely goes off 100% of it. HF can do hydrogen bonding. So the Ka for HF is very low. So what does that mean? At equilibrium, we have mostly what? H pluses or HFs?
HFs.
We have mostly HFs, and that's why HF is considered to be a weak acid. Sodium fluoride. So if we take a look, these are the 6 strong acids. You should have these memorized. I know in the day of age that we are in, you're not likely to take an examination without something in front of you that you could cheat on if you're gross, right? But we would normally have people memorize these. It's easy because all of these are halogens, right? You need your periodic tables off too. All of these are halogens. So we have hydrochloric acid, hydrobromic acid, and hydroiodic acid. All of these are 8s. These are polyatomic ions that end in 8. Nitrate, perchlorate, sulfate. Nitric acid, perchloric acid, sulfuric acid. Pretty cool. All of the above are monoprotic except for who? Why? You got it. This is diprotic. Diprotic. One of the acids listed above is, we got that. What did an acid of triproteism be? So what is an example?
Phosphoric acid.
Phosphoric acid. Good. Or, as Claudia said, H3PO. 4. Easy enough. This is a list of the strong bases. Guess why these are strong bases? Because their Kb is very high. The Kb is more like the solubility product constant because these are solids. So it's basically based off of their solubility, right? Kb. Yep, it's the basic equilibrium constant. So it's very high for these. You notice that we have alkali metals. All of the alkali metals are monobasic. Then we have calcium, which would be dibasic. Why does calcium have 2 hydroxides? What did you just say?
So it's Ca2+.
Because the calcium has a +2 charge, right? If you have your periodic table, you recall right up here, the +2 charge for calcium, +1 for all the alkali metals. Can anybody give me anybody but Akshay give me a tribasic base? Yes. Did you not have me last semester?
I have. I have the 4.
Huh? Yeah, let's come up with one. What'd you say? Nope, doesn't exist. Aluminum hydroxide. Why is aluminum hydroxide tribasic? It has a +3 charge. Remember, silver, zinc, and aluminum. What else would I have accepted with Akshay? Iron what? Iron 3? Hydroxide. Yeah. FeOH3 would have also been accepted. Anybody else want to play the game?
The 2 boron.
Boron would not work. It's a semi-metal. Copper has 1 and 2. Copper 1 and copper 2. No, that won't be 3 though.
Okay.
Right? It would be diprotic. Silver? Silver only has 1.
Thallium.
Nickel, you could have nickel 3. Yep. Good.
Thallium.
Thallium. I'm not sure. We never use that much.
Would it be something like,
But like, if you recall, there's certain oxidation states, but you don't know if you know that number, but there's certain charges we always use last semester. Like cobalt 1 or cobalt 2, chromium 1 or chromium 3, right? There's these trends with the ones that they can make. All right, so that's out of the way. Now we have properties of acids and bases. So here they are for acids, here they are for bases.
okay, I know it's
Do you ever
not-
feel something slippery like soap?
I don't tend to. want to make it acid.
You ever felt orange juice? You ever seen lemon juice?
Right, like orange is not like sugar, other stuff.
How you know these acids don't? No, I'm just kidding. It's citric acid that's that sour taste, right?
So I did the sour.
Yep. But slippery on your skin like soap or detergents. Didn't you ever get your mouth washed out with soap? That'd be a base. Yep. Never got your mouth washed out with soap.
Oh, I remember the first time.
Claudia, no?
That discouraged me.
You seem like somebody that would cuss a lot.
My grandparents threatened to do that with me once, and my friend told them if they ever stopped. They would never talk.
Yeah, right. My babysitter, she would take the bar of soap and like rake it across the top of your teeth. Right? It's probably child abuse today.
Your babysitter?
Yep.
I agree that I think that would be so.
I wasn't a big cusser. My dad actually never, I probably have only heard him ever cuss like 5 or 6 times.
That's
And I don't
not
even
right.
like, yeah, right, on my whole life. Kind of crazy.
Why?
That's, I didn't cuss that much either, I think because of it, right? You usually inherit behaviors from watching
I don't
others.
know what's wrong.
It wasn't until like 4, what'd you say, 4 what?
It's like
Trauma,
trauma.
yeah. I think, yeah, like 4th or 5th grade, like I was around, I became some friend with some kid that thought it was cool to cuss.
I just think it's expressive. People know what you're.
My dad,
It's like
my dad,
psychology to it too.
my dad. expressed that-
Oh, that's kind of funny, right? So feels slippery and smooth. Which one does that sound like? Base. Has a sour taste.
I mean,
Acid. Stings and open wounds. Akshay, do you want to argue with that?
I feel like they both would
Could be both.
It would be both.
Wait, how does,
actually would be.
how does
Hey,
Akshay
I
do
mean,
that?
wouldn't-
Akshay, how do you know that?
Well, that's like when you get like soap in the cut, it hurts.
Oh, yeah, it's okay, that makes sense.
Right?
Yeah.
Soap in your eye versus lemon juice in your eye. Don't they both sting?
I think acid sting more.
One
Actually, I would rather get HCl in my eye than sodium hydroxide.
one test that
If you get a drop of sodium hydroxide in your eye and you don't get it out quickly, you probably lose in that eye.
Wow.
But wait, it's not, it's like dehydrated?
No, it just reacts with the fats in the cells.
Oh.
Like actually versus HCl, you know what's in eye drops? Acids.
Oh,
Got it.
cool.
Reacts with metals to form hydrogen gas.
Acid.
That is an acid. Have you ever seen the movie Saw? And the Saw guy's like, Sydney, you were bad with your hands and did hurt, damage people with your hands. So I locked you up and you can reach in and get this key. And like the key is like in this jar of acid. And then it's like vaporized, like you can see bubbles coming off of it. That would be the hydrogen gas forming, right?
Oh, the bubbles.
So that's in the metal key will be all reacted.
Well, this like smash the jar.
Oh, that's good.
Okay. But then what if the key falls down and you're handcuffed like this,
Oh.
When you're dead.
right?
Well, it's better
And I think
than-
something's gonna like come in and like
It's
squash
better
her or
than
something
nothing
too.
at all.
The Saw guy was pretty mean, right?
Just don't hurt anyone in the first place.
Yeah, and then you won't get solved. Hopefully, I don't know. If you guys probably aren't old enough to watch these movies. It's like 18, right?
I've never heard of.
Rated R. You never heard of the Saw guy?
I watched like, I
Wait,
I
like,
watched the other
Saw?
concept. I've never seen
Yeah, like don't you ever watch Rick and Morty? And he's like, "What are you gonna do, Marty? You gonna saw us or whatever?" We're getting solved, right? Yeah. Has a bitter taste. This is why the babysitter would rub the soap on your tooth. Base. Conducts electricity in solution. Well, let's take a look.
Oh,
Sodium hydroxide and water will break into sodium ions and hydroxide ions. HCl and water will break into hydrogen ions, and chlorine ions. Ionic compounds dissolved in water or molten allow the transfer of electrons because you have the free moving ions. So it's both.
Why do you sound so certain to get your stuff?
To tell you the truth, I don't know how Johnson & Johnson babies, whatever, doesn't. Like the tier list stuff. Yeah. Our big topic of today, if you were in one of the other classes, they're much better teachers than me, so you probably have already learned this. So if we take a look, we had you memorize HCl. What is HCl's name? Hydrochloric. We had you memorize HNO3. What is HNO3's name?
Nitric acid.
Yeah, right. So even if they did teach you last semester, it doesn't seem like you remember it. All right.
You were in class.
Okay. Well, you should have had those memorized then.
We did.
We did last semester.
I was giving them a chance to say it.
All right. So if we take a look, these are all acids and bases, and this is going to be your homework for tonight. So make sure you pay attention. If it is not an oxyacid, meaning it is not a polyatomic ion with oxygen in it, it is called a hydro. To start it off with, for example, HCN, we now have no oxygen, even though it's polyatomic ion, there's no oxygen, it's not an oxyacid, it starts with hydro. Instead of cyanide, we take off the IDE and we add ic to the end. So it'd be called hydrocyanic acid. HBr, HCl, H2S. These do not have oxygens as well, so HCl is called hydrochloric acid. H2S would be called hydrosulfuric acid, as this is hydrobromic acid. HI, very hard to say. Hydroiodic acid, good, good. So those are the ones that do not have the oxygen. They don't have the oxygen. Good. If you have 8 or ite, you recognize this as chlorate or sulfate or chlorite or sulfite, then you don't have hydro. You drop 8s and put ic for sulfur, sulfic. Sulfic doesn't sound good. Sulfic, huh? Sulfic. You're sulficing, right? Like it doesn't sound right. Sulfic. Sulfuric, right? So we do a little change with sulfur. So that becomes sulfuric. And then ites become usses. So chlorite becomes chlorus. And sulfite, again, not sulfus, but sulfurous. Phosphite and phosphate become phosphorus and phosphoric. So there are a few changes there. The cool thing about bases is I did teach you how to do that last semester. You just name the polyatomic, or you name the cation with its name, and then you the hydroxide is always going to be the anion for most of these. Easy enough. The only problem is, what if your what if your cation has multivalence? What do you need to show? The Roman numeral, right? You got to show the Roman numeral. So on the back of your periodic table, you have those polyatomic ions. What is ammonium's formula? NH4, or you have these memorized if you're good. What's the charge of it? +1. What is hydroxide formula? OH. What's the charge? -1. What's the least common multiple of 1 and 1? 1 divided by 1 is 1 ammonium. 1 divided by 1 is 1 hydroxide. Done. Ammonium hydroxide. Right? Easy. Ammonium hydroxide. This is it's a big oxidizer. This is like, you ever see in the movies like where they have that white powder substance and they're using it to blow like a building up? Yeah, ammonium hydroxide. Before that's weapons grade. But if you were trying to this is the one that like terrorist groups would want. What's the what? That is a 4. That's part of the ammonium. What, the Mandalorian? Hydrochloric acid, boring. HCl. Why is there only one H? Nope. Because chlorine has a one charge, -1 charge, right? Let's do perchloric acid. What is perchlorate? Man, that's called teamwork. What is the charge of perchlorate?
Minus
-1. So what are we gonna have to put in front of it? 1H. The cool thing is chlorine has a -1 charge. All of the chlorate, hypochlorate, hypochlorite, chlorite, all of them have a -1 charge too. Same thing with sulfur. Sulfur has a -2 charge. Sulfate has a -2. Sulfite has a -2. Phosphorus has what charge? Phosphorus. -3. Phosphate, phosphite, -3 as well. So that makes it very easy, right? If you're doing this from memory, right? How about lead 4 hydroxide? What is lead? What is the charge of lead? +4, it's written first. So it's a cation. So that means how many hydroxides do we need? 4. Claudia is on it. I'm Super Saiyan on this. Yep. If we take a look at the bottom here, we are switching it over. So H2S. Is there an oxygen? No. So we know we need to start with what? Hydro what? Sulfuric. If you have hydro, it ends in ic. Sulfuric. And it's an acid, so we should put what? Acid. What is it? Yeah, actually, it was in the musical. They had somebody spell the actual LSD. They actually had them spell the whole thing. I don't know if you caught that. He didn't say LSD. I thought if I was up there, I would have been like LSD. Because that'd be kind of funny, right? You still get kicked out probably, but it'd been funny. I believe that one of these posters that you see is actually LSD, so you can actually see the formula and see there's an acid. But what does that mean? If it's an acid, what must it do when it's added to water? What does it have to do if it's added to water? No, it's an acid. What does it have to do? No. It increases the what? This is the first thing we talked about today. Yeah, it increases the hydrogen ion concentration, right? That's why it's an acid. Okay. You've never, yeah. It's sour? You want me to call my opera roommate about it? Yeah. Huh? Hint. No, yeah, Chad would probably know too. All right. SNOH2. What do we got? What is SN? They never met.
10.
10, good. Is 10 in group 1A, 2A, silver, zinc, or aluminum?
Nope.
Nope. So it needs a what?
Roman numeral.
Oh, and it is 10 hydroxide. What's the charge of hydroxide? So what must your charge a 10 be? Yeah, 1, 2 divided by 2 is 2. So plus 2. 10, 2 hydroxide. I think this pen makes my handwriting look worse. Two. Ian Fisher said he doesn't know Roman numerals. I don't believe that. He said nobody ever taught me. I can count to 10 in Roman numerals. Hold on 1 second, guys. We're gonna pause and low. Claudia, go for it. Oh, we don't have time. I'm sorry. Last one. We don't have time. I got to do the lab too. So what is this last one? What is the last one here? Acid or base? It is an acid. Good. It's an acid because it increases the what? What happens is this H right here comes off. But what is the name of this acid?
Succeeded.
This can be rewritten as HC2H3O2, can't it? So that would be acetate, which would be acetic acid. All right, cool. So finish that box up, front and back of that box up for tomorrow. Am I up there? Yep, I'm up there. All right, so what I want to show you guys is a little bit of what they're going to do in the laboratory tomorrow. I actually have already made all the stuff for the cabbage, so they don't have to worry about boiling it. Now, is it imperative that you clean everything in this laboratory? Yes. And after you clean everything, if you still have soap residue in there, you need to rinse it out with distilled water, because distilled water has a pH of what? Right. And if you have soap residue in there, that's going to make your pH look what? Basic. Yeah, right? There's nothing worse than being basic. That's from the movie. Oh my God. This guy. All right, so what you have here is cabbage juice. Yeah, cabbage is actually purple. I'm gonna get some fresh cabbage juice. Cabbages are purple. But what do we call this cabbage? Geez, I can't pour. I don't think so. But thank you. It's a floral cabbage. So if we take a look, what color? Purple. Right? Why do we call this red cabbage then? So this is a base. This is sodium hydroxide. Watch what happens when I add the base to it.
Whoa.
Why didn't they call it green cabbage? Because when you eat cabbage of this type, what is it served with? Vinegar. Vinegar. So if we take a look there, what color is that? Red. And that's why it's called red cabbage, because the only person that knows that is Mum. Right? So basically what you're going to do is you're going to set up with known pHs 2, 4, 6, 8, 10, and 12. You're going to put cabbage juice into all those. And then you're going to test things like Sprite, baking soda, all of these different things, and you're going to get the pH of them. Right? So after you do that, then you're going to take a glass stir rod and you're going to stick it in there and you're going to test it on pH strips. Huh? Yeah, this is kind of a fun one. We're getting you guys set up for next week's lab. Now, if you take a look on this strip, I put the base up here, which is green, and the acid down there, which is red. After you get that done, then you are going to use the pH meter. This is very important. We're going to unscrew this, lift this up, and then put this over to the side so that we don't knock it over. Because there's liquid in here and we don't want it to spill out. We need this always needs to be soaked. The way you use the pH meter is you stick it down in there and swirl it around so that it touches it, and then you take the reading. Because we're showing that all of these are effective ways to get the pH. And then which one do you think is the best way? You got it. And the pH meter will be what we actually end up using to calculate the hydrogen ion concentration, because we know that the negative log of the hydrogen ion concentration is equal to the pH. So using log functions, you should be able to reverse that to find from the pH, the hydrogen ion concentration.
Mr. Jackson.
What's up?
So if the litmus paper turns like blue, it's a base, and if it red, it's acid.
Actually, this is universal paper right here. But yes,
Okay.
with litmus paper, blue is base, acid is red. Is that what he said? Now, this is not the only indicator that is available. This cabbage juice, there are more scientific indicators. We usually leave on that one, but I want to show you a few of these at least. So I'm going to take and I'm going to put some acid in some of these. 1, 2, 3. And I'm going to put some base in the other ones. 1, 2, 3. This is an indicator known as thionyl blue. What color do you think it is?
Blue.
Blue. It's orange.
What?
So if we put it in the acid, it turns red. And if we put it in the base, what color do you think it's going to turn? Blue. Right?
So, yeah.
This is bromocresol purple. What color do you think it is?
Yellow.
Yellow. If we put it in the base, it turns yellow. And if we put it in the acid, it turns. Do I have these switched? I'm sorry. If we put it in the acid, it turns yellow. If we put it in the base, it turns purple. Now this is bromocresol purple.
Oh, I forgot about that.
Bromocresol green turns green in the base. You think I'm joking? It really does.
I have so much familiarity with
Why couldn't they be drinking?
Yeah, right? Yeah, I'm just confused. This is phenolphthalein. What color do you think it is? Phenolphthalein? Clear.
Oh,
If we put it in the acid, it does nothing.
looks like.
Because they're black.
This is actually the active ingredient in
Oh, looks like
laxative. If we put it in the base, what color do you think?
orange. Red. Whoa, I don't think.
Purple, pink. That was actually a very useful thing in occupied countries by the Nazis, because this is on there. But take a look. If I spray this with a base, I've got a message. And when this dries, guess what will happen?
Go away.
It'll go away. So they would write messages in phenolphthalein and then spray them with a base.
Imagine they got too wet.
Huh?
They got too much wet. We got, like,
Yeah, right.
like,
Thank you guys very much. Sorry about holding you a little bit later. If somebody has a problem with it, tell them to email me. Thank you guys very much too.
Sunshine.
We will see you guys.